Welcome to Episode 2 of our PMI-ACP Certification Study Series. In this episode, we'll cover Value-Driven Delivery, which falls under Domain 2 of the exam content outline. Question 11. What is Value-Driven Delivery and why is it the highest weighted domain on the exam? Take a moment to think about your answer before we continue. Domain 2 Value-Driven Delivery carries a 20% weighting on the PMI-ACP exam, making it the single most important domain for your preparation. Understanding why this domain matters so much will help you approach these questions with the right mindset. Value-Driven Delivery is about ensuring that the team always works on the highest value items first, maximizing return on investment early in the project lifecycle. This sounds simple, but it requires a fundamental shift in thinking for teams accustomed to traditional project management. In traditional approaches, value delivery typically happens at the end. You spend months gathering requirements, designing, building, and testing. Only when everything is complete does the customer receive any value. This creates enormous risk. What if you built the wrong thing? What if the market changed? What if the customer's needs evolved? You've invested all that time and money before discovering the problem. Agile flips this model. We identify the most valuable items and deliver them first. This generates return on investment immediately rather than at the end. It also creates opportunities for feedback, allowing us to correct course before investing too heavily in the wrong direction. Value, importantly, is subjective. It's defined by the customer, not by the team. A feature that seems critically important to developers might matter little to users. A feature that seems trivial to the team might be the difference between a customer choosing your product or a competitor's. This is why Agile emphasizes close collaboration with customers and stakeholders. They define what's valuable. For the exam, you need to understand both the qualitative aspects of value, meaning what the customer actually wants and needs, and the quantitative financial metrics that support value-based decision-making. The PMI-ACP tests your ability to use tools like return on investment, net present value, and internal rate of return to compare options and make informed prioritization decisions. One more thing, value isn't just about building the right features. It's also about not building the wrong features. Every feature carries ongoing costs in maintenance, testing, and complexity. Sometimes the most valuable decision is to say no to a feature that doesn't justify its cost. This connects to the lean principle of eliminating waste. Question 12. Can you explain ROI, NPV, and IRR and how they're used for prioritization decisions? Take a moment to think about your answer before we continue. The PMI-ACP exam tests your understanding of financial decision metrics. These tools help us compare different projects or features objectively, supporting value-based prioritization. Let me walk through each one. Return on investment, or ROI, is a percentage metric that measures the efficiency of an investment. The formula is straightforward. ROI equals net profit divided by cost of investment multiplied by 100. So if you invest $100,000 and generate a net profit of $50,000, your ROI is 50%. For the exam, the rule is simple. Higher ROI is better. When comparing two projects or features, choose the one with the higher ROI, assuming other factors are equal. However, be aware that ROI has limitations. It doesn't account for the time value of money, and it doesn't consider the scale of the investment. A small project with high ROI might generate less total value than a larger project with moderate ROI. Net present value, or NPV, addresses the time value of money. The core insight is that a dollar received today is worth more than a dollar received next year. Why? Because you could invest today's dollar and earn interest. NPV calculates the present value of all future cash flows, both positive and negative, discounted by an appropriate interest rate. The formula looks complex, but the concept is simple. You're answering the question, if I had to pay a single lump sum today instead of receiving or paying money over time, how much would that lump sum be? If NPV is greater than 0, the project is profitable. If NPV is less than 0, you'd lose money. When comparing multiple projects, choose the one with the highest NPV. For exam purposes, you probably won't calculate NPV by hand, but you need to understand how to interpret it. A question might present two projects with their NPVs already calculated and ask you which to select. Choose the higher NPV. Internal rate of return, or IRR, is the discount rate that makes the NPV of all cash flows equal to zero. Think of it as the project's effective interest rate, the expected annualized growth rate. A project with an IRR of 20% effectively grows your investment at 20% per year. For the exam, higher IRR is better. It indicates more efficient use of capital. However, like ROI, IRR has limitations. It can be misleading when comparing projects of very different sizes or durations. Let me give you a practical example of how these metrics work together. Imagine two features under consideration. Feature A costs $50,000 to develop and will generate $100,000 in revenue over 2 years. Feature B costs $200,000 to develop and will generate $350,000 in revenue over 2 years. Feature A has an RO1 of 100%, 50,000 profit divided by 50,000 investment. Feature B has an ROY of 75%, 150,000 profit divided by 200,000 investment. If you only look at RO1, you'd choose Feature A, but Feature A generates 50,000 in total profit, while Feature B generates 150,000. If you have the capital available and the capacity to execute, Feature B creates more value despite the lower RO1 percentage. This is why considering multiple metrics provides better insight. For exam scenarios, don't assume one metric is always correct. Understand what each measures and apply them appropriately. ROI measures efficiency, NPV measures total value accounting for time, IRR measures effective growth rate. A well-rounded decision considers all relevant factors. One more point, these financial metrics help with prioritization, but they don't replace judgment. Market timing, strategic alignment, risk, and customer relationships all matter. A feature with lower ROI might still be the right choice if it retains a key customer or opens a new market. Question 13. What is risk-adjusted prioritization and why should high-risk items be tackled early? Take a moment to think about your answer before we continue. Value-based prioritization isn't just about value, it's about value relative to risk. This concept is absolutely critical for the exam and for real-world practice. The naive approach to prioritization is to rank features by value and work from the top. The problem is that some high-value features carry significant risk. Maybe they depend on an unproven technology. Maybe they require integration with an unreliable third-party system. Maybe the requirements are poorly understood. If we defer these risky items until later in the project, we might discover catastrophic problems when it's too late to recover. The agile approach is to calculate priority as value divided by risk. Items with high value and low risk are obvious priorities, but items with high value and high risk should also move toward the top of the backlog. Why? Because we want to fail fast. Failing fast sounds counterintuitive, but it's actually about learning fast. If a critical technology isn't going to work, we want to discover that in Sprint 1, not Sprint 10. Early failure gives us time to find alternatives. Late failure often means project cancellation after significant investment. Let me give you a concrete example. Imagine a project that requires integrating with a new machine learning AP1 that your team has never used. The API is central to the product's value proposition. In traditional project management, teams often defer difficult technical challenges, hoping to figure them out later. They focus on the features they know how to build, creating a false sense of progress. In Agile, we would create a spike, a time-boxed research task, early in the project. Spend 2 days exploring the AP1. Can we make it work? Does it deliver the accuracy we need? What are the limitations? The output of the spike isn't working software, it's knowledge. That knowledge converts an unknown into a known, allowing for accurate planning. For exam scenarios, if a question describes a high-risk item being deferred until later phases, that's usually the wrong approach. The correct answer typically involves confronting risk early through spikes, prototypes, or prioritization of risky items. There's a related concept called green shifting that you should understand. This is an anti-pattern where projects report green status because all the easy work is being completed, while difficult, risky work is postponed. The project looks healthy based on velocity and burn down charts. Then suddenly, it hits the deferred risks and turns red catastrophically. The status was an illusion. Agile prevents green shifting by demanding that we confront risk early. If the project is going to fail, we want to know as soon as possible while there's still time to adapt or cancel. For the exam, remember, high value plus high risk equals early priority. Spikes address technical uncertainty. Failing fast is about learning fast. And beware of scenarios that describe deferred risk or suspiciously green project status hiding unaddressed challenges. Question 14. What is the Moscow prioritization method and how is it applied? Take a moment to think about your answer before we continue. Moscow is one of the most commonly used prioritization techniques in Agile, particularly in Dynamic Systems Development Method, or DSDM, from which it originated. The name is a mnemonic for 4 categories: must have, should have, could have, and won't have. The O's are just there to make it pronounceable. Must have items are critical requirements for the current delivery time box. Without these, the release has no value. Think about a banking application. The ability to log in is a must-have. Without it, nothing else matters. The system cannot function. Must-haves define the minimum viable product. Should-have items are important but not vital for the current release. They can be temporarily worked around. Using the banking example, a forgot password feature might be a should-have. It's important for user experience, but for the first week of launch, the support team could manually reset passwords. It's not ideal, but the system functions without it. Could-have items are desirable but less important. They're the nice-to-haves that improve the experience but don't fundamentally affect functionality. Maybe it's a dark mode theme or customizable dashboard layouts. If time and resources permit, we include them. If not, we defer them without significant impact. Won't have items are explicitly out of scope for this time box. This category is more important than it might seem. By clearly identifying what won't be included, the team prevents scope creep. Stakeholders know not to expect these features. The team knows not to work on them. Explicit exclusion is often more valuable than vague prioritization. For the exam, understand how Moscow supports scope management. In Agile, particularly in DSDM, time and cost are often fixed while scope is variable. If a sprint isn't going to complete all planned work, should-have items are dropped before must-have items. If there's extra capacity, could-have items are pulled in. A common exam scenario might present a situation where the team realizes they can't complete all committed work. The correct response involves identifying which items are true must-haves and protecting those while negotiating which should-have or could-have items can be deferred. One subtlety: the classification isn't permanent. An item that's a could-have for this release might become a must-have for the next release based on customer feedback. Prioritization is continuous, not a one-time exercise. Also understand the percentages often associated with Moscow. A common guideline suggests that must-haves should not exceed 60% of the total effort. This creates buffer capacity for the unexpected. If a team commits 100% of their capacity to must-haves, any surprise or delay causes failure. Building in margin with should-haves and could-haves provides flexibility. For exam questions, Moscow helps manage scope, communicate priorities to stakeholders, and make informed trade-off decisions when constraints force choices. Question 15. How does the Kano model help us understand customer satisfaction and prioritization? Take a moment to think about your answer before we continue. The Kano model, developed by Professor Noriaki Kano, provides a sophisticated framework for understanding how features affect customer satisfaction. Unlike simple prioritization that treats all features equally, Kano recognizes that features have fundamentally different relationships with satisfaction. The model identifies three primary categories. Basic features, also called threshold or must-be features, are requirements that must be present. If they're missing, the customer is extremely dissatisfied. But here's the key insight. If they're present, satisfaction doesn't increase. It's merely neutral. Think about hot water in a hotel room. If there's no hot water, you're angry. You'll write a terrible review. But if there is hot water, you don't write a glowing review saying, "This hotel has hot water." It's expected. Its presence doesn't delight. Its absence infuriates. Performance features, also called linear or one-dimensional features, have a direct correlation between execution and satisfaction. More is better, less is worse. Think about battery life in a smartphone. If it lasts 4 hours, you're somewhat satisfied. If it lasts 8 hours, you're more satisfied. If it lasts 12 hours, you're very satisfied. There's a linear relationship. Improvement in these features directly improves satisfaction. Excitement features, also called delighters, are the most interesting category. If these features are missing, the customer doesn't care. They didn't know to expect them. But if they're present, satisfaction skyrockets. Think about the warm cookies some hotels offer at check-in. Nobody books a hotel for the cookies. Nobody is disappointed if there are no cookies. But when you arrive tired from traveling and someone hands you a warm chocolate chip cookie, you're unexpectedly delighted. For prioritization, the Kano model provides important guidance. Basic features must be present regardless of other considerations. You can't skip them to work on delighters. No amount of warm cookies compensates for cold showers. Performance features provide reliable returns on investment. Improving them consistently improves satisfaction. Delighters differentiate you from competitors and create memorable experiences, but only after basics are covered. Here's a critical insight for the exam. Feature categories change over time. Yesterday's delighter becomes today's performance feature, becomes tomorrow's basic expectation. When smartphones first included cameras, it was a delighter. Then better cameras became a performance feature, where more megapixels meant more satisfaction. Now, a camera is a basic feature. A smartphone without a camera would be rejected regardless of other features. Wi-Fi followed the same trajectory. Hotel Wi-Fi was once a delighter. Then it became a performance feature where speed mattered. Now free Wi-Fi is a basic expectation. Hotels that charge for Wi-Fi face customer anger. For exam scenarios, the Kano model helps explain why certain features should be prioritized differently. A question might describe a team trying to decide between improving a basic feature and adding a delighter. The answer depends on whether the basic feature is already satisfactory. If basics are covered, delighters differentiate. If basics are missing, delighters are worthless. Question 16. What voting and estimation techniques are used for group prioritization? Take a moment to think about your answer before we continue. When multiple stakeholders have input on priorities, Agile provides techniques for gathering that input efficiently while building consensus. Let me cover the main approaches you'll encounter on the exam. The 100-point method gives each stakeholder 100 points to distribute among candidate features. This forces stakeholders to reveal relative value rather than simply marking everything as high priority. If a stakeholder places 50 points on a single feature, they're signaling that it's dramatically more important to them than other options. This prevents the common problem where stakeholders rate everything as a must-have because there's no forcing function for trade-offs. Dot voting is a participatory technique often used in workshops. Features or options are posted on a wall, and each participant receives a set number of dots, typically 3 to 5. Participants place their dots on items they consider most important. Multiple dots can be placed on a single item. The result is a visual heat map showing group priorities. This technique is fast, inclusive, and builds visible consensus. Monopoly money operates similarly to the 100-point method, but uses play money to simulate budget constraints. Stakeholders are given a fixed amount and must allocate it across features. This makes abstract prioritization decisions feel more concrete and often reveals different preferences than abstract rating exercises. Buy a feature gamifies prioritization. Features are priced based on their estimated cost. Stakeholders are given budgets and must literally buy the features they want. This forces trade-off thinking and often sparks valuable discussion about why certain features matter. For exam scenarios, these techniques are appropriate when you need to gather input from multiple stakeholders, build consensus, or make relative priority visible. They're particularly useful in sprint planning, release planning, or roadmap sessions where stakeholder alignment matters. The key exam insight is that these techniques prevent the situation where everything is marked high priority. By forcing allocation of limited resources, whether points, dots, or money, they reveal true relative priorities. Watch for scenarios where a product owner is overwhelmed by stakeholders claiming everything is critical. Facilitated prioritization exercises help resolve this. Question 17. What is minimum viable product and how does it relate to incremental delivery? Take a moment to think about your answer before we continue. Minimum viable product, or MVP, is a term you'll encounter frequently, though it's often misunderstood. MVP represents the smallest collection of features that delivers meaningful value and enables validated learning. It's not about building something small and unusable. It's about building just enough to test assumptions and gather real user feedback. The concept comes from lean startup methodology. The idea is that extensive upfront planning often builds the wrong product because assumptions about user needs are unvalidated. Instead of spending months building a complete product based on speculation, you build an MVP, release it to real users, and learn from their actual behavior. That learning informs the next increment. For exam purposes, MVP connects to several agile principles. It supports early delivery of value by getting something useful to customers quickly. It enables responding to change because feedback from the MVP informs subsequent development. It embodies simplicity by maximizing the work not done, building only what's necessary to learn. Incremental delivery is the broader practice of releasing working software in progressive increments. Each increment adds functionality to the previous release. This differs from traditional waterfall where the entire product is delivered at once at the end. The benefits of incremental delivery include earlier return on investment since customers gain value before the project is complete, reduced risk because problems are discovered early when they're cheaper to fix, better alignment with actual needs since each increment provides feedback that shapes subsequent development, and improves stakeholder trust because visible progress replaces speculation. For exam scenarios, look for questions about how to structure delivery or respond to uncertainty. The answer often involves delivering a small increment first, learning from it, and adapting the plan. If a scenario describes extensive planning before any delivery, that's typically the wrong approach. One nuance. MVP doesn't mean poor quality. The M stands for minimum, not mediocre. The product must be viable, meaning it actually works and provides value. Releasing a broken product teaches you nothing useful. The MVP must be good enough that user feedback reflects their actual experience with a functioning product. Question 18. How would you handle a scenario where the team must choose between two high-value features? Take a moment to think about your answer before we continue. Let me walk you through a typical exam scenario for Domain 2 and show you how to reason through it. Scenario: the product owner presents two features for the next sprint. Feature A has an estimated business value of $50,000 and involves well-understood technology. Feature B has an estimated business value of $70,000 but requires integration with a new external AP1 that nobody on the team has used before. The team has capacity for only one feature. Which should they prioritize? Let's break this down using the concepts we've covered. First, consider pure value. Feature B is worth 40% more than Feature A. If value were the only consideration, Feature B wins. But we need to consider risk. Feature A uses well-understood technology, so the risk is low. Feature B requires unknown integration, introducing significant technical risk. What if the AP1 doesn't work as expected? What if there are hidden complexity or compatibility issues? Now apply the value divided by risk framework. Feature B has higher value but also higher risk. Feature A has lower value but lower risk. The ratio might actually be similar. Here's the key insight. The exam typically expects you to address risk proactively rather than avoid it entirely. High risk, high value items should be tackled early to fail fast, but there's a nuance. With only one sprint of capacity, can we tackle the risk responsibly? The recommended approach would be to start with a spike, a time-boxed investigation of the AP1. Spend a day or two exploring whether the integration is feasible. If the spike reveals that the API works well, proceed with Feature B. If the spike reveals problems, we've learned this early without committing an entire sprint. For this exam question, the correct answer likely involves not simply choosing the higher value feature without considering risk, not avoiding the higher value feature because of risk, proposing a spike to reduce uncertainty before committing. If no spike option is presented, choosing Feature B with a risk mitigation plan. The distractor answers might include choosing Feature A because it's safer, which avoids the question of risk management, choosing Feature B without any acknowledgement of risk, which is naive optimism, escalating the decision to management, which abdicates the team's responsibility, demanding more information before deciding, which delays unnecessarily. The correct answer demonstrates that you understand both value and risk and that you know how to manage uncertainty through agile practices like spikes. This pattern, applying multiple concepts together rather than using a single rule, is common in PMI-ACP questions. You're being tested on integrated understanding, not isolated knowledge. Question 19. How should a team respond when stakeholders discover a delivered feature doesn't meet their actual needs? Take a moment to think about your answer before we continue. This scenario tests your understanding of feedback loops, learning, and the agile response to discovering that assumptions were wrong. Scenario: the team has built a feature according to the approved specifications. During the sprint review, stakeholders try out the feature and realize it doesn't actually solve their business problem. The specifications were followed correctly, but the specifications themselves were flawed. The stakeholder is frustrated. What should happen next? Let's start by reframing the situation. In traditional project management, this might be treated as a failure. Someone must have gathered requirements poorly. Someone approved the wrong specifications. Blame needs to be assigned. In Agile, this situation is actually the system working correctly. The sprint review exists precisely to gather feedback and catch these misalignments. The problem was discovered in weeks, not months. The cost of the mistake is one sprint of effort, not an entire project. This is dramatically better than discovering the problem after full deployment, when changes are expensive and users are disappointed. The concept at play here is double loop learning. Single loop learning asks, are we doing things right, meaning efficiency? Did we follow the process? Did we meet the specifications? By those measures, the team succeeded. Double loop learning asks, are we doing the right things, meaning effectiveness? Did we solve the actual problem? By this measure, we have more work to do, but we've gained valuable information. So what should happen next? The product owner updates the product backlog based on this new understanding. What does the stakeholder actually need? How should the feature be changed? This goes into the backlog as new work. The incorrect feature might be removed, modified, or serve as a prototype that informs the corrected version. The team should not be criticized for building to specification. They did what was asked. The learning is that specifications themselves were insufficient. Future mitigation might include earlier prototyping, more frequent stakeholder touchpoints, or better wireframing during requirement development. For the exam, incorrect answers might include blaming the team for not understanding the real requirements, demanding that specifications be more detailed in the future, which actually makes the problem worse, proceeding with the flawed feature because it meets specification, treating this as a change request requiring formal approval. The correct answer embraces learning and adaptation. We've discovered important information. Now we adapt the backlog to reflect that learning. This is agile working as intended. There's a related concept called ikiwisi, which stands for I'll know it when I see it. Many stakeholders can't fully articulate their needs until they see something concrete. Specifications based on abstract discussion often miss the mark. This is why Agile favors frequent delivery of working increments. Each increment lets stakeholders see and react, progressively refining understanding. For exam preparation, remember that discovering you built the wrong thing is not a failure if you discover it early. The failure would be delivering the wrong thing to production and only learning from user abandonment. Sprint reviews are the mechanism for early discovery. Use them. Question 20. What are the principles of agile contracting and how do they support value delivery? Take a moment to think about your answer before we continue. Traditional contracts often become obstacles to value delivery. They lock in scope, creating adversarial dynamics when change is needed. Agile contracting approaches seek to align incentives around value rather than compliance. Let me walk through the main agile contracting models you should understand for the exam. Fixed price work packages represent a middle ground between pure time and materials and pure fixed price. Instead of fixing the price for the entire project, which requires knowing all requirements up front, you fix the price per iteration or set of iterations. The customer commits to funding the next 3 sprints. At the end of those sprints, they evaluate what was delivered and decide whether to continue. This reduces risk for both parties. The customer isn't locked into a multi-year contract. The vendor isn't held to specifications that will certainly change. Graduated fixed price creates incentives for early delivery by sharing savings. The contract establishes a target price, say $1 million. If the vendor delivers the essential functionality for less, perhaps $800,000, the savings are shared. Maybe the vendor keeps $100,000 and the customer saves $100,000. Both parties win when value is delivered efficiently. This aligns incentives around efficiency rather than maximizing billable hours. Money for nothing, change for free is perhaps the most agile-friendly contracting model. Money for nothing means the customer can terminate early if they've received sufficient value. Perhaps after 6 months, the customer has everything they need. Rather than continuing to fund unnecessary work, they can end the contract, paying a termination fee that's less than the remaining contract value. The vendor gets fair compensation for foregone work. The customer stops paying for things they don't need. Change for free means the customer can swap scope without renegotiating. They can remove a planned feature and replace it with a different feature of equivalent size at no additional cost. This enables responding to change without the adversarial dynamics of traditional change orders. For exam scenarios, these contracting models address the tension between the certainty customers want and the flexibility Agile requires. Questions might present situations where a traditional contract is blocking adaptation. The answer typically involves proposing more flexible contract terms that align both parties around value delivery. Key principles underlying Agile contracts include collaboration over negotiation, partners seeking mutual success rather than adversaries protecting against each other, working software as progress, payment tied to delivered increments rather than completed phases, embracing change, contract mechanisms that enable rather than penalize scope evolution, shared risk and reward, both parties invested in the outcome rather than just the deliverables. One common exam scenario involves a customer requesting a change that violates the original contract. The traditional answer is to process a change order, requiring renegotiation and often creating friction. The Agile answer, assuming appropriate contract terms, is to evaluate whether the change improves value and enable it. If so, the contract should facilitate this rather than obstruct it. Remember, The goal is customer satisfaction through valuable software delivery. Contracts should support this goal. When contract terms obstruct value delivery, the contract terms are the problem. That concludes episode 2. We covered 10 important concepts. Take time to review these questions and answers, and practice applying these concepts to scenario-based questions. In the next episode, we'll continue exploring the PMI-ACP exam domains.